So thanks for having me. It's great being here. Thanks to Robert and Daniel for giving me the opportunity to speak. What we're going to discuss today is just a general overview to testing. I'm going to talk about what is testing, why do you need testing. It's not going to be too technical, all right? So if you already have some experience, I hope it's not too boring, okay? I was planning on doing like a quick live demo at the end where I can actually show off how you can test some small web application, which unfortunately, since technical issues, we can't do today. But I'll just walk you through the code on GitHub real quick and see to make the best out of it, I guess. Right, quick bit about myself. Who am I? Well, my name's Hans, like I said already. I'm not a front-end dev, okay? Most of you here are full stack or front-end devs. I am not. I actually have a Java and C# background and just recently got started with Ruby. So if you see any code that looks like garbage, is not my natural habitat, okay? I am tutoring at the Technical University, so I'm helping out with teaching there. Coincidentally in the subjects testing and software quality assurance. So you see how this works. Yeah, and I myself am a big fan of testing. Why do I like testing? My first job was in a testing firm. And yeah, I like testing because it like protects us from the code, from the evil that is code. Okay, what do I mean by that? No program is kind of hard. A lot of people have written about how software today kind of sucks. I remember an article I read that was titled "The Coming Software Apocalypse." It was really like, oh my God, we're all gonna die. Problem is, software is really complex today, and that causes a lot of issues, okay? What I mean by software is very complex. Quick guessing game for you all. What do you reckon an average car, like not average, but luxury car today, like smart car, how many lines of code does the software in that car, just the software that stirs the car and everything, how many lines of code are in there? You reckon it's gonna be 1 million? Is it gonna be 10 million or 100 million? Give me a show of hands so I know you're not asleep. Who thinks it's 1 million? Okay, one, all right. Who thinks it's 10 million? 10 million lines of code in the car? Bunch of people. Who thinks it's 100 million? Just one, okay? It was a trick question. It's actually 600 million lines of code, okay? 600 million lines of code for a freaking car. That's what we've come to. Complex code means a lot of errors, all right? You know, it's like you touch some piece of software and basically it breaks as soon as you like poke at it. An example I always give for critical software errors is the story of the Ariane. Anyone has a clue for what the Ariane is?
A rocket.
Exactly, yeah, it was a rocket that was built in 1996 by the European Space Agency. And the story about Ariane is a rather sad one. They built this thing, they developed it for 10 years, cost about 400 million bucks. Then they launched it and it went up like 4 kilometers and then it blew up because someone didn't convert some floatings into ints properly and the rocket did like a flip and it went bang. Okay, 400 million lines of code because of a teeny-whiny error. That was more than 20 years ago. A more recent story, maybe you followed Uber, self-driving cars. There has been an issue with one car in the beginning of August. The car basically ran over a pedestrian, like full stop, just went through. And they found out, well, it registered her, well, no problem with the sensors, but for some reason the car decided not to stop. Okay, so it just went, which is very sad. So we have some issues with software. There's a bunch of problems. What can we do to avoid these issues? Obviously, we do testing, okay? So it doesn't matter if you talk about cars or web applications or just small functions. The concept's always the same. You have some component, some system, and it's supposed to do something. In the way of like a car is supposed to stir properly. Your web application is supposed to display some values properly. This function right here is supposed to divide some numbers, calculate the division. Easy peasy. How do you know if it works? Well, how do you check if your calculator works? You try it out. Type in some numbers. Does it display the correct result? If it does, so good. If not, you found an issue. This is what testing does. You take your system in some state, precondition. You chuck some values in there, and you check if what it puts out is correct. That's basically it. This is a test. Okay. What's the issue with this piece of code? Yeah. So what input would make that fail? Yeah, if b is 0, exactly. In any other language, if this was not JavaScript, it would be an issue. This is JavaScript, so it just puts out infinity. So if you want your code to behave that way, then it's actually correct. Might be a bug in the JavaScript language. I don't know. Might on feature, we might argue that, yeah. So we got covered what a test is. It's always the same. Input, output on some system, okay? What does testing mean? Now, I said you check if it works by putting some stuff into it. Actually, it's kind of wrong. Actually, testing is the process, it says here, of executing a program or system with the intent of finding errors, and that's the important part. You don't test to check if it works. You test to check it doesn't work. You reveal errors. Basically, there's this comic that says, compares programmers or developers to testers, and the programmers like, I'm making something, and the testers like, I'm breaking something, and that's really what this is about. Why do you want to break your stuff? Because if you break it, someone else doesn't have the opportunity to, right? If you find an error, you hopefully will fix it, not let it go to production, and then it won't fail in production. That's good. We want that. Why do we want that? Why do you actually care if you produce work in software? I personally think it's a bit of our responsibility, personal responsibility as developers. We build stuff for the world to run on, okay? We want that stuff to work. We don't want to contribute to the hellscape that is programming today, okay? We want to build nice things, and I hope you all kind of want to do that. If that noble goal doesn't cut it for you, want to save your dignity and money, because errors that live in the wild are pretty expensive. Like a rocket blowing up that costs 400 million, pretty expensive. If you find that issue, spend half an hour testing something, finding the issue, fixing that a bit cheaper. Yeah? And also, especially in the security scene, where you have issues with security, that can cause a lot of embarrassment if you have problems, security issues or bugs, stuff like that. Yeah. So in reality, combination of both, I think this should make it clear why you want to test. Good. So I got the motivation covered, hopefully. Now we're going to talk about the types of errors that you can reveal with tests. The thing is, I said testing is the process of finding errors. Okay, which errors? There's a bunch of errors that can happen, many different errors. We don't have time to cover them all. So we're just going to talk about regression tests or regression errors. What's a regression? It's something that if you've developed for more than a week, you've already seen that. It's this situation, you develop some wonderful feature. You build it, and let's say you test it. You make sure it works. So you try it out, try to break it, and it doesn't break. All good, you say. You push it to production, it's fine. Let it run there. You work on some other stuff. 3 months later, you decide to, let's try my old feature again. Like, just coincidentally, you touch it, it breaks. You're like, what the actual? That's a regression. You have something that used to work, now it doesn't, and everyone's like, what happened? Yeah. To avoid these kind of errors, you have regression tests. Okay? So, what do people do in reality to avoid regressions? I've actually worked with places or seen places where each time they have a release, let's say you have a release of some big piece of banking software every 6 months, they had a manual test suite with several thousand tests. And they would, before each release, they would take a month with something like between 15 and 20 testers, and those testers would run a manual regression test suite for a month out of 6 months development time, okay? So if you have lots of features, lots of stuff to test, regression testing is gonna take a lot of time. We're developers, we're lazy, we don't wanna spend a month testing something each time we release it, especially in today's world, we have to release fast, we can't really do that. Enter automation. luckily, smart people have developed a bunch of tools to allow us to automate this process. So you don't have to, each time you change something, manually see if it still works. You can instead write your tests like code. So you see it here. There's some, I don't even know what the framework is. Basically, you write the test code, and that will do this process of putting stuff in, checking if it works automatically. And the good thing is, well, you spent some time developing the test beforehand, but now you can rerun those tests at the press of a button. And you see that here. You don't even have to press something, like the framework just detects if anything changed. If you change your code, it's going to rerun your test, and it goes like this. Okay? So test automation can really help you avoid these doing the same thing with testing over and over again. What in an application can you test? So we got covered, okay? What kind of errors do we check? Where are we going to check them? If you have some application, there's very many ways to, or many things to actually test. The most intuitive thing would be, let's assume you have an application that has this email input field where people enter the email and they say okay, and then at some point they're going to get sent a registration mail or something like that, okay? The intuitive thing maybe would be to have your automation system really interact with the application. You'd have the web thing with the input field and the button, and your framework would interact with that input field, type something in automatically, press a button, and at some point it would check some mail server if an email with the correct content has arrived, right? Would work, but there's other ways to test your application. You don't always have to test the whole thing together. That's why I say the whole system end to end. You can also simply take some components out of that system and test those like in isolation. That's, for example, an integration test where I test components together, or a unit test where you test a single component. For example, just the class that sends mails, that gets a string and it sends a mail, you test that. Why do you do that? Two things. First of all, each of those levels, so to speak, reveals different errors again. If you have a unit test that's very good at uncovering issues that are related to functionality, some small issue with a component. Integration tests much better with finding issues that occur when different components don't quite work together as well as they should, right? Or end-to-end tests. Imagine these really do basically what a user does, so they're often called acceptance tests that would detect like stuff like, is a button actually visible? Because it will actually try to click the button, and if it isn't there, well, you found that. So good at different things. That's the theory part. Oh no, it's not quite, sorry. The other thing with these levels is that they have they have different costs associated with them. Unit tests are very easy to write and they're very quick to run. End-to-end tests, not so much. They're harder to write, take longer to execute. And this is where the testing pyramid is going to come in. Who has already seen that before today? Free. Okay. How many times, like Daniel, how many times have you seen this in the talk? Exactly. You're all gonna, I'm happy that I'm the first one to actually show this to you. If you attend any test about talking at all ever again, you're gonna see this. It's very, very popular because it's true. It tells you how should you automate how should your automation test suite look. Lots of unit tests, bunch of integration tests, not too many end-to-end tests. So it's a balance between cost and risk. What kind of issues can you find? How much money do you want to spend? That's it with theory, but alas, there's no live demo. Instead, I whipped up a quick application that I would normally, how do I get out of full screen? No, it doesn't work here. Something Control P.
Shift F. Command Shift F.
Command Control Shift F. No, Command Shift F. Yeah, we got it. I'm not a Mac user, in case you haven't noticed. All right, so I whipped up a quick application that I prepared a test suite and would normally run that. We quite can't do that. So instead, I'm going to show you the application. I will show you the tests I wrote, and you just have to imagine that they actually run, okay? If you can do that. Use your fantasy. So let's look at the application first. Fair word of warning. I had to come up with an idea, what am I going to build that's easily testable and demonstrate some concepts of testing. And the only thing my brain could come up with was, let's make an application where you manage kittens that fight each other to the death kind of thing. I don't know. So this is not it, because that doesn't work. Sorry about that. Oh, come on. Enter, right? Why doesn't it go on enter? Oh my God. Did I mention I'm not a Mac user? Jesus. What do I need to do? Don't hit enter, all right. What?
Also copy the
Yeah.
output.
Okay, how do I copy it? Command C?
Maybe just click the link.
Command T.
Oh, there we go.
No.
Hit enter.
No, not enter. I'm not going to hit enter.
Click the wrong enter.
Command C. And now?
Would also press enter. Maybe just open a new tab with Command T. And now try it with this one.
Okay, can I paste something here?
Yeah, Command V. And then. Backspace or there or something. Showing that to
Caps lock? Maybe like that.
this one, right? What the hell is going on?
Maybe we found a bug through testing.
Okay, copy paste again and then click on the link in the drop down. Click on the link.
Ah, fuck! Okay. Like that?
Yeah. I've never witnessed something like this. This is crazy. Maybe
You have another browser?
Maybe, does it need HTTP?
Browser?
Does it need like an HTTP in front, maybe? I don't know.
But
Should?
you have Safari, right?
You should
Yeah,
have.
just go.
Go command space and try Safari.
Exactly.
Yeah.
Can I press enter now?
It should work. There we go.
The demo guys are with us today.
What the heck?
There we go.
I love that shit. All right. Sorry?
We need tests for Chrome.
It's piss, so. All right, so. Right, so I made this monstrosity. You can see you have a list of kittens, all right? And it's fairly simple. You can also edit and delete them. Let's have a look at some kittens. I don't like that one. Please.
You test didn't work.
Didn't test it. No, what's actually happening?
Test it on Safari.
I didn't test it on Safari. That's exactly right. Okay, we'll just have to do it that way. So as you can see, you can put in some stuff, and it should hopefully, yeah. So it will update this score that tells you how murderous this kitten is. Okay. And so what can you test? You can do unit tests or end-to-end tests. Let's look at. Oh my God, not the same thing again with GitHub. How can I add to a new tab? Jesus Christ. Okay, github.com. So I'm gonna just quickly show you what the unit tests could look like, all right, for that. And like I said, you will have to imagine that they just work. Let's see. Right. So this is an Angular application. It doesn't really matter that it is. Just gonna have a look. So this, what I showed you, that the score that's calculated, that's a perfect example for a thing you can unit test, okay? Because it's fairly simple, just takes some values and puts out the number. So let's look at what the code looks like. So that's it. Doesn't really matter what the syntax like. You have this component, the battle score service. Well, has a method to calculate battle points that takes a kitten and returns a number, okay? And what does it do then? Well, if the kitten's null, there's nothing to return, it returns 0. Otherwise, it takes the attributes of the kitten, cuteness, speed, blah, 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 and calculates your battle points. Easy peasy. So very clear what the function is, very easy to test. Unit test, right? This is a unit, a simple component, simple function to test. Now let's have a look at the test, a bit more stuff. Still can't move, so I have to imagine me pointing. So this is a test file, and remember what a test looks like. Just remember back. You have a component, you have some input, and you have some expected result. We're going to use that here. First of all, you can see in like the line 6, line 9, we create a system, the thing that we want to test. In this case, it's a battle score service, the component we want to test, or calculator, whatever. And then we have actual test cases that start with it in line 12, 20. Okay? Let's look at the first one, line 12. First of all, it has a name. What does it do? It should return a correct battle score, and then you set up your input. Remember, the input of the battle service function was a kitten. So we create one with its attributes, strength, and so forth. The next line after that is the actual execution of the test, where we take the function and we put stuff in. This is our actual let's do it part, and then we record the result. Now, the last thing we have to do, we compare the actual result with what we get back, and that's the expect. Expect the result, that what we actually get with what we want, should be 10. And similarly, we test if it works for null. Easy peasy, right? Normally, it's an issue of just executing a command, in this case ng-test, and this will run all your tests automatically and will also watch your files for changes. And if you break your application, you refactor it, and you do something bad, it will show you, well, you have an issue. Easy peasy. Let's have a look at the end-to-end tests. So this is the component, a single component that we can test. And go back to the application. Something that lends itself to an end-to-end test would be scenarios like, does it display the list in the index correctly? Or when I press delete, is it actually removed from the list? Or if I edit it in the edit field, is it actually updated in the index? Things like that. So multiple views needs the whole application. That would be an end-to-end test. And we're going to have a look at what an end-to-end test looks like. Angular, luckily, makes it fairly easy to set this kind of stuff up. Like I said, I'm not a front-end dev, so I'm pretty happy. And you'll already notice when we look at this app spec end-to-end test file, it's a bit more involved, right? You have stuff like page.navigate to. I mean, the concept is the same. You do something, and then you have an expectation, an expected result. But you see, gets longer, involves more pages. For example, in line 25, we just check if we click the button, remove it from the list. And you see it's already getting a bit like longer and needs more syntax. Also, maintenance is harder. You see that we get items by selecting the links in the actual HTML, all right? Imagine if you change that up. If you use CSS selectors and you change your CSS, your tests are going to break. That won't happen with your unit tests. Good. How the hell am I going to get to my presentation, Chrome? Where was it? There it is. OK, so that was the practical part. Sorry again, that didn't work out. Let's summarize what we've learned today. First of all, programming is its own kind of hellscape, which I hope you don't have to learn too much. But testing can help you with that. Okay? We learned about regression tests, why use them, and we also talked about what test automation and test levels is. So I hope I didn't give you too much stuff, like, okay, very risky show of hands. Who's kind of like, this was a bit too much for me, like, who's like that? Show of hands. Okay, 1, 2, all right, too fast. Who could follow along nicely and understood most of stuff? Okay, thank you. And who's like, I don't give a, okay, never mind. So that's for the summary. If you're interested to learn more about testing, first of all, just send me a message. I'm always happy to help people out. Like I said, I'm very passionate about testing. Let me know what you think. Let me know if you have some problems with testing something specific. Talk over that. And there's some great books, Art of Software Testing or The Art of Unit Testing. And you can also visit the Ministry of Testing website. They have great resources. So if that's it from my side, you can check out the slides, hosted them with Reveal.js. Gonna have a look at the other thing. What was it? Remark.js. Gotta check that out. And yeah, do we have time for questions?
Sure, but thank you for the talk.
Yeah, thanks a lot.